All right, welcome everyone. All right, my name is Matt Garman. I'm the Vice President of our Compute Services for AWS. I've actually been part of AWS for 12 years since we started back in 2006. This is my 7th reInvent, and everyone gets bigger and a wide swath of things that we get to announce. But the most fun part for me is listening to kind of the customer stories that we get to hear throughout the week, and it's really energizing to see all of you here and to learn what you guys are doing. Now, we have a huge customer base that uses compute. Anybody in here, just a show of hands, anyone who does not know what EC2 is? Good, all right, good, we're set there, I don't have to start with that. But it's been a fun week for us already, and just talking to customers and hearing about what they do, it is amazing at the scale that people are really using the platform. So last week, I was talking to a customer, and really just trying to understand how you use the scale of AWS, right? And one in particular was chatting with Western Digital, and they were trying to think about how do they go and do HPC, embarrassingly parallel simulations, to go build the next version of hard drives. So what did they do? They decided to say, all right, we're going to try to do it all at once. Usually these simulations take about 20 days. They once said, I don't know, there's no reason why I need to take 20 days. Using a suite of AWS tools, Spot, Fleet, and I'll talk about some of these later in the presentation, they tried to run them up. They ran a cluster of over 1 million vCPUs. They ran 2.3 million simulation jobs. Took about an hour to scale those all up across the fleet. I think they did it across 3 availability zones in US East. Scaled that workload up, ran that 1 million CPU cluster at 99% utilization for 6 hours, scaled back down after an hour, and they were done. They did the entire simulation in 8 days instead of 20, or 8 hours instead of what normally would have taken them 20 days. And they didn't really talk to any of our team. They told us afterwards. It was pretty cool, and they did a lot of that on Spot to save a bunch of money. That was maybe what I thought was going to be the most interesting thing that I was going to see in a customer example that I saw, until one of our customers this week pretty much overshadowed any live demo that could ever be done on Monday when JPL live streamed launching a device on Mars and successfully landing it, which is, that is a gutsy live demo to pull off. The scheduling around reInvent was also pretty impressive, but some really cool things that customers are doing. All right, and because of that, and you heard Andy talk a little bit about this, but AWS is the market segment leader for the 8th consecutive year. I think that's when they started counting, was probably before that too. But a lot of these stories kind of talk about the scale of AWS. And you guys have all seen a lot of these graphs around infrastructure as service and magic quadrants, and AWS is always at the top corner, which is great. I think the interesting part about this graph, though, is that as you've seen time go over a period of time, there are way fewer dots on the screen. People just kind of keep trailing off as it's really hard to keep up. And there's going to be fewer and fewer of these dots, and AWS is extending their lead in that leaders quadrant. And how do we get there? Because we're customer obsessed. We really think about what customers need. In fact, 90% of our roadmaps, and some of our product managers are here today, 90% of what we build on our roadmap comes from customers. We listen to you, we listen to your problems, we either build what you guys ask, or we think about your problems and think about innovative new ways to solve them. But a lot of that comes from our conversations and our interactions with you guys, the customers. And that's why we design what we do. Then we're talking about the compute platform. One of the common questions I've actually been getting asked this week is, what is your vision for EC2 and compute in general for AWS? Really, we want to be the compute platform for the world. Any compute, anywhere, any type of thing that you want to be able to accomplish, we want to help you accomplish. And we need to, and in order to support that, we need to support that through continuous innovation. When we first launched EC2, there was a single instance type. It didn't even have a name, it was just called instance. And now we have a wide range and a broad swath of offerings across many different types of dimensions and things like that. And all of that is different innovation that helps you guys drive and deliver any application that you need. And that's it. We want to support virtually any workload anywhere. And that's the focus of what we're going to talk through, is some of the innovations that we're delivering that help you guys deliver on those applications that you really can, anything that you guys can think of. It's a broad swath of options, and it includes lots of building blocks under the covers, all sorts of different dimensions, and I'll talk about a bunch of verticals there. It means you have to have great security and governance. It means you have to have world-class networking and storage. And it means you have to have abstractions that make it easier for you, that help you cut costs, and it means you need to have compute everywhere. All right, so we're going to start with choice, and what do we provide in the base layer of the compute infrastructure? Today we provide 3 key ways of thinking about like high-level constructs of consuming compute. We think about EC2 instances, which is the first thing we offered, but increasingly we're making big investments in the areas of containers and serverless and Lambda as well. I think particularly interesting, and I think when we first started launching a lot of our containerized services and a lot of our serverless offerings, customers were saying, oh, how do I build? Do I decide if I'm going to do instances or if I decide if I'm going to do serverless? And increasingly what we're seeing is customers using all 3 of these as part of the very same application. They're thinking about how they mix and match, they're thinking about how they can combine them all together, and they're thinking about the right piece of compute for the right workload. And I think that that's really the right way to think about that and the right way to combine a bunch of these things. Let's start with instances, though. We have a huge swath of offerings and different options for you to pick with inside of our instances so that you can have every workload. Whether it's OS choice of Linux or Windows, whether it's architecture choice. Traditionally, we've supported x86. A couple of weeks ago, we launched support for AMD instances, the new EPYC processors, and now ARM was announced on Monday, which we're really excited about, and we'll talk a bit more later. We have different types of options for all different types of workloads. We have things like bare metal. We support local disks. We support attached disks, network attached disk. We have a ton of different networking capabilities for all sorts of use cases. We have the richest set of third parties. And for our partners out there, we really thank the partners in the ecosystem. That is a lot of what makes AWS go. And that's really a lot of what's compelling about AWS and how it makes it easy to run your applications. And finally, we have lots of different ways that you can purchase compute as well, all designed to give you guys more choice. Let's start with Linux. We have a rich set of Linux options across all sorts of vendors. We have enterprise distributions like Red Hat and SUSE. We have a broad swath of open source choices, everything from Ubuntu to CentOS to many more. Really, any Linux distribution that you can think of is available on EC2, and there's lots of customers running it. And one in particular I want to talk about is Amazon Linux. Amazon Linux is our own Linux distribution that we put together. We kind of optimize the packages, we optimize the runtime to really work really well inside of AWS and EC2. Earlier this year, we launched Amazon Linux 2. It's kind of the next version of Amazon Linux, and there's a couple of key features to it. One is for those enterprise applications or things where you know you need to have long-term support, where you need to know that an operating system is going to be there and not change underneath the covers for a long period of time. We announced 5-year support for Amazon Linux 2, so you can know that that distribution is going to be there and available for you. We give you free security and ongoing maintenance patches, of course. It's optimized for AWS with all the modern tooling, so all the kind of modern tooling and ways that you want to install packages and choose the packages for your own images. We support VMs, and we also support Docker images, so this works for your containerized applications as well as your EC2 instances. And we have broad support for a wide range of ISVs. Amazon Linux 2 is also available to use on-premise or anywhere else. So you can, many people run it in AWS. It's by far the most popular distribution, has the most number of customers inside of AWS. But lots of people are starting to run it on-premise too, so they can have the same virtualized platform in their own data centers as they use in top of AWS. Windows is also extremely popular, and you heard Andy talk about this for those of you who heard the keynote this morning. Windows workloads on AWS continue to grow really rapidly, even in the face of Linux taking market share. We have 10 years experience running Windows in EC2, and we have full Windows stack support, .NET, Active Directory. We have SQL Server, both run an EC2 instance as well as in RDS, where you can have managed SQL Server offering. We have all of the latest versions of Windows and SQL Server. And there's an interesting new benchmark that's coming out. I think it's being published today, but they're letting me share it earlier, that an independent benchmark, not one run by us, not one run by Microsoft, showed that SQL Server actually has 2x better price performance on AWS than the next major cloud provider. Pretty cool. And we offer you the ability to bring your own license, which is really big. I'll give you one example of a customer that is a big Windows user on top of AWS, is Cisco Foods. You may have seen these trucks driving around. They kind of say Cisco on the side of the truck. And they're a big customer that uses food distribution, really kind of a back-end supplier to large companies that are buying kind of food in bulk. Cisco was running a bunch of Windows on-prem. They decided there was a hurricane that was coming and was going to hit their data center, or they thought it was going to hit their data center. They were incredibly worried that their entire operation was going to go offline, and they decided to use that as an excuse to move everything into AWS. They actually used it as an excuse to also upgrade Windows. They could be on the latest version of Windows. They did that entire migration, shut down their data center before the hurricane hit, and have successfully been running on AWS since. Now, IDC published a report that shows that almost 60% of the Windows workloads running in the cloud are actually running on us today. It's more than twice as much as the next closest person, and it just shows that really when you have a great infrastructure with a lot of different options, everybody will come and use it, which we're excited about, and we love running Windows and Linux workloads. But we want to make it easier to bring your own license as well. And so today, I'm excited to announce the AWS License Manager. License Manager is free to use for everyone, and it allows you to track your BYL licenses for use, either in the cloud or on-premise or really anywhere you're running that license. As we know, and as you've heard many times, many of these software vendors are not always the most customer-friendly. Occasionally they'll try to audit you, occasionally they'll try to catch you into using too many licenses, and when they do find that out, it can be a really unnecessary and unhappy bill that you get in the mail from them. License Manager helps you avoid that. You can track all of your licenses, track usage, enter your rules of how many you're allowed to have, can licenses move between machines, what can peak usage be, et cetera. You can track, make sure that you have governance over your licenses. We support Windows, SQL Server, SAP, Oracle, et cetera. We think this is a great offering for enterprises that have their licenses. They want to get the most out of them, and they want to be able to use them in the cloud knowing that they're not going to go over and get a nasty bill from these guys. Now on the processor front. We have the broadest choice of processors available anywhere. We have Intel, and we've had Intel running on us for a long time, and that's really exciting, and I think many of the instances that you guys have run for long periods of time run on Intel. In addition, we support NVIDIA GPUs for a lot of our machine learning workloads. We have the fastest machine learning instances available in the cloud, and a great partnership with NVIDIA to keep driving that innovation and make sure you always have the latest and greatest when you're thinking about GPUs. And AMD, I mentioned we launched earlier, where customers can save money using AMD instances. And earlier this week, on Monday, we announced the very first AWS Graviton processor. I'll get to some of those in a second. First with Intel. A couple of instances I wanted to highlight we've launched recently. This year, about a month ago, we launched our high memory instances. These are designed for really large in-memory databases, things like SAP HANA. All of these instances are SAP HANA certified, and they support 6, 9, and 12 terabytes of memory, which is really crazy. We did a cool thing where we launched, and we were able to, we had a customer who wanted to run a 6 terabyte in-memory database. And on-premise, it took them about 8 hours to get, once they had the server, to get that thing up and running. In AWS, they were able to get it fully up and running, starting from the launch command in 45 minutes, which sometimes sounds like a long time, but if you have to load 6 terabytes of data, actually it takes a long time. But there's still 45 minutes from 8 hours if you think about disaster recovery or things like that is a really huge improvement. We've announced that we'll have 18 and 24 terabyte instances coming next year. And we also, one of those customers that are using these large instances is Whirlpool. Whirlpool has migrated all of their SAP databases, SAP instances, onto AWS using R5, Z1, and they're looking at 6 terabyte instances as their database continues to scale vertically as SAP HANA instances do. We also announced the Z1D earlier this year, which has by far the fastest speed for a single core of any instance in the cloud. It has a 4 gigahertz single core speed that you can run all the time. And that's really important, particularly when you have expensive software applications that are licensed on a per core basis. One of the big use cases for this is EDA, where there's really expensive software there. Synopsys uses Z1D instances in the cloud and have been able to reduce their time to run many of their modeling by 35% using Z1D over the next fastest processor that they used to use. We've also announced earlier this week new options for HPC networking and machine learning. We announced the C5N instance. Peter went into this a little bit earlier this week on Monday, and many of you might have missed that. But C5 instances introduce 100 gig networking for the first time inside of AWS. So you can get 100 gigs inside of a cluster, unconstrained bandwidth That allows you to grow really, really large clusters and really deliver on the HPC promise, particularly when you're thinking about large interconnected workloads like MPI. Another really cool, interesting use case for C5N is loading data from S3. You actually get 100 gigs of networking from a single EC2 instance from S3 uploaded. I actually had some of my team test this. Accounting for a little bit of TCP overhead, they were actually able to get 97 gigabits sustained pulling data from S3 into an instance. If you're thinking about loading a Hadoop cluster or anything like that, that is a material difference in how fast you can really get up and running or doing data scanning over S3. We also announced the Elastic Fabric adapter, which allows you to do kernel bypass. So for those of you doing high-performance computing, you can get up to 15 microseconds or below 15 microseconds latency in between nodes when you're doing MPI-style workloads using OpenLib Fabric. We also announced the P3DN instance. This is a brand new instance on the GPU family, also introduced with 100 gig networking, and as well has twice as much onboard GPU memory as the P3 instance for really, really large machine learning models. Fast AI is one of our big machine learning customers, and they will consume as much GPU and as much memory as possible. They love trying to cluster these together, actually, with the 100 gig networks and the more GPU memory to really see what kind of models they can do. This is kind of like a research institute, and they're really interested in doing, seeing what boundaries they're able to push with our new instance types. In addition, customers like autonomous vehicles, where they have a really big model that they're trying to all fit into memory so that they can get the absolute best performance, are really excited about these options. AMD. These are AMD instances, for a while, kind of AMD was out of the server game, but their new EPYC processors are actually really great. They have great performance, and they have a fantastic roadmap. Many applications aren't actually that CPU bound. They don't need the highest end CPUs. What they need is a reasonable amount of CPUs, a decent amount of cores, and some memory to do some general purpose workloads or high memory workloads where CPU isn't the bottleneck. For those, they're fully x86 compatible. You can simply use your same images and launch these onto AMD. We have M5As, R5As, and coming soon T3As that save 10% over the standard version if you're able to run well in an AMD processor. And we think it's a great idea for many of these workloads for customers like you that are able to save 10%. We actually, and we're incredibly excited to announce this week, our A1 instances. These run with the AWS Graviton processor. ARM-based cores. This is the very first cloud-based ARM processor launched anywhere. And for a whole host of use cases, customers can really save a bunch of money. I was talking to Don McCaskill from SmugMug last night, and he was saying he's on our customer advisory board, and he had an early sample of some of these A1 instances. He's estimating that for many of his workloads, his scale-out workloads, he's going to be able to save 40% by moving them onto ARM-based for many of his PHP stack applications. Really interesting, and we're excited to see where this goes. I think we're also excited to see how this helps grow the ARM ecosystem. I think we've been really excited to see how ARM has taken off over the last couple of years, and there's a lot of interesting development going on. There's great support for Linux. A lot of the tools are already compiled to use with ARM, and we're interested to see how you guys will use these, particularly for scale-out workloads. You also have your choice of accelerators. We've had Elastic Graphics for a little while. It allows you to attach a little bit of graphics accelerator to any of your EC2 instances. For those of you that are running gaming or other sort of visually intensive things, and visually intensive workloads, this allows you to add a slice of graphics GPU to your instance and kind of get that graphics acceleration. And then just this morning, we announced Elastic Inference. Similar to Elastic Graphics, Elastic Inference allows you to attach a slice of inference to any instance. You can launch an M5, an R5, a C5. You can kind of mix and match the right ratio of CPU and memory, but attach a little bit of GPU inference from 1 to 32 tops, depending on the needs of your application. For a lot of inference workloads, this will significantly speed up your response times, and it helps you really reduce the costs because many inference workloads can't take advantage of a full CPU. All of these things help combine to give us the broadest and deepest choice of platform. If you think about all of these, you can kind of combine the right category, the right type of instance. You can think about the capability, what's the processor platform, or the amount of memory, or do you need bare metal, or do you want virtualized? You can think about accelerators. You can think about adding EBS. All of this combines to give you virtually unlimited set of options for every workload and business that you need. And a lot of this innovation is enabled by what we call our Nitro system. Nitro is our reimagining of the virtualization stack. This is an effort we undertook about 4 or 5 years ago to really, from the ground up, build our virtualization stack. We thought about how do we virtualize, historically virtualization has all been done by the hypervisor and x86 cores on a server. We said, if we can take that and move it into an offload card or a Nitro card, we can get much better performance out of our virtualized network. We can get much better virtualized I/O performance out of storage, both local storage and EBS. And we can custom build a hypervisor that only does the bare minimum in order to time slice the CPU or provide rock-solid security for our customers. And so that's what we did. We have a Nitro chip custom designed for this implementation that's on the motherboard that attests from a security perspective that the exact bits and BIOS that we expect on the system are what they are. We have a custom-made hypervisor that provides bare metal-like performance even for virtualized instances. And Nitro gives fantastic performance on networking and storage, and I'll walk through a couple of those later. These modular building blocks allow us to really rapidly deliver new capabilities. One of the capabilities that really emerged from Nitro is as we looked at the increase in containerization, we looked at containers, we looked at serverless, and we said, you know what? VMs aren't exactly the right construct for that. We love the hardware virtualization security that you get with VMs, and that was really important to us, and that's one thing that we don't compromise on. So in fact, we don't ever put customer Lambda instances in the same, different customer Lambda instances in the same instance, Lambda functions on the same instance. Same for Fargate. When you think about our serverless offerings, we always make sure that customers are isolated at an instance level because we trust that hardware security boundary. But we know that's not efficient. We know instances take a long time to load. If you think about how long it takes you to launch an instance or how long it takes you to load a Linux operating system, it takes a long time relative to how fast you'd like to have serverless respond. So we designed Firecracker. Firecracker is a micro VM architecture. Effectively, it takes the virtualization starting from a base KVM layer. It has a minimized device model, and it allows us to provide that same hardware virtualization, but in a much, much smaller footprint. The footprint of a Firecracker is a little under 5 megabytes. And what it allows you to do is launch these VMs at an incredibly rapid rate with low footprint. You can launch a micro VM using Firecracker in under 125 milliseconds. You can launch 150 micro VMs a second per server. This enables an incredible scale, incredible elasticity. You can pack thousands of these on a server. And we wanted to solve this problem for everybody. So we open sourced this program on the Apache 2.0 license, and it's available for any of you guys to go download on GitHub. I haven't looked today, but yesterday, 24 hours after we launched, we already had 2,000 stars on GitHub and was at the top of the trending list. So it seems like people are really excited about Firecracker like we are. And we've already seen several of our first pull requests for new features. So you guys can go do that. Please add more. All right. So Firecracker really says, when we think of the broadest and deepest platform choice, we talked a lot about instances and what we're enabling from that underlying service. But Firecracker really enabled us to really push the envelope on what we could do from a serverless perspective. And if we think about containers, Fargate is our serverless container offering. Fargate is something we are really excited about and have seen incredible growth over the last year as customers migrate their applications to stop having to worry about clusters, right? Cluster management is what a lot of these container orchestration engines do, but it just means you have to manage a cluster. A lot of customers don't want to have to do that. You can bring your existing code. It's fully Docker compatible. It's production ready. We've gotten all of the certifications. We're rolled out in 9 global regions with 7 more coming at the end of this year, so we'll pretty much be rolled out with Fargate everywhere. And Fargate really simplifies using containers. All you have to do is launch your tasks or launch your container instances, and that's it. You don't have to worry about anything else. We do the scheduling. We do manage the cluster under the covers. You don't have to worry about patching. You don't have to worry about any of those things. All of the power of serverless. We also have native AWS integrations for networking, security, monitoring, tracing, et cetera. Fargate runs tens of millions of containers in AWS for AWS customers every single week, and that number is exploding and growing up every single day. Last year and last April, we also launched EKS, which is our managed Kubernetes offering. And we have 2 container services. One is ECS, which is our integrated native AWS service. It really tightly integrates with all of our AWS services like IAM policies and ELBs and things like that. And we wanted to bring a lot of that to EKS as well. Many customers run Kubernetes inside of AWS. In fact, if you look at every Kubernetes production implementation, and this is by an independent third source, they look at every Kubernetes implementation, whether it's on-premise, in a cloud, et cetera. More than half of those are already running in AWS, kind of before we even launched EKS. Many customers are moving to there for the ease of management, though. People, turns out, don't love managing and keeping a etcd highly available. It's actually really hard to run Kubernetes at scale for production applications. It's pretty easy to get up and running. I'm sure many of you have gotten up and running and done some quick Kubernetes work quickly, but running it at scale is hard. Running it highly available is hard. That's what EKS helps you do. There's a couple announcements that I want to announce today. The first is in-place upgrades for Kubernetes. So if you need a new version of Kubernetes, and this is an open source project that's that's moving incredibly rapidly, so new versions come out all the time. As opposed to having to take downtime or shut down your instances and launch new instances or new clusters, you can now do in-place upgrades of the version and always take advantage of the newest Kubernetes capabilities and versions that are available. We're also announcing that we have ISO and PCI compliance, and we're going to be launching, by the end of this year, we'll be launching EKS in many of the rest of our global regions, including Singapore, Sydney, and many of the others. By the end of this year, we should be in almost every region globally with EKS. And I think at this point you probably have seen like 1,000 of these logo slides, but here's more. We have tons of customers that are running inside, running containers on top of ECS and containers generally. I'll call one out in particular. You guys may have heard of this small restaurant customer, McDonald's. They have a lot of customers. It turns out that McDonald's serves 64 million people every single day. It's a lot of hamburgers. It is in 37,000 locations, 64 million people a day. And McDonald's wanted to add home delivery to their options. They wanted to quickly have an architecture that could scale to support 20,000 orders a second. They built this all on ECS, quickly launched it over a few months, and now we're successfully running it around the world, quickly rolling out a home delivery option, all in the AWS container services. Serverless, and I'm going to go through containers and serverless pretty quickly. There's many deep dive sessions. Unfortunately, we also have a number of new services coming out that are supporting containers and serverless. However, most of those are going to be announced at Werner's keynote tomorrow. So I can't talk about those here, so there's a little bit less to share with you. But stay tuned and please go to his keynote tomorrow to see many of the other services that we're going to be launching, continuing support of our container and serverless offerings. However, there are a couple things I do want to call out with regards to Lambda. This is actually one of the most impressive stats that I think I've seen in all of reInvent. Lambda is running trillions of executions every month with hundreds of thousands of active customers. That is an incredible scale. Really, the pace at which people have jumped onto the serverless way of computing really kind of surprised all of us, and I think the ways in which people are thinking about innovative ways to leverage Lambda as part of their applications, either as a whole kind of switch to serverless, or as I mentioned, key parts of their application that they use to supplement either containers or instances, has been really exciting for us to see. Lambda has many of the certifications that you need to run your infrastructure. And actually, much of Lambda is running underneath, or has Firecracker running underneath, which enables many of the fast start times and things like that that you guys are excited about. We also have logo slides for that. Lots of people are running on Lambdas. One in particular that I want to call out is Autodesk. Autodesk has been a long-time AWS customer. And so they jumped on the serverless bandwagon and wanted to see what they could go build with Lambda and serverless as well. They built an account provisioning application called Taylor. And previously, this was a hugely labor-intensive process for them. They had 2-week turnarounds to provision new accounts. They wrote that whole thing on Lambda, moved it all there, saved tons of time, and now all of their accounts are automatically provisioned through a number of Lambda functions. All right, that was a quick overview of many of the new building blocks and things that we're doing inside of many of our compute services. I want to quickly touch on some of the new things that we're doing in security and governance. That's one of the critical things. That's kind of a don't pass go, don't collect $200 if you don't have great security. Now, when I first started in EC2 back in 2006, The most common thing that customers would say is, hey, how can my data and how can my implementation possibly be as secure in AWS as it is my own data center? That has totally changed. At this point, customers now accept it as given that AWS implementations can and should be more secure than they could ever do in their own data center, as we have orders of magnitude more people thinking about security, thinking about how we can provide tools that make it easier for you to build secure environments. And that, we have 30% more security tools, we have lots of governance tools, et cetera. There's a ton of building blocks that help you be secure inside of the cloud. I'm going to call out a couple of these new ones that I think are particularly interesting. The first one is Resource Access Manager. This is one that we're launching today, and there's a couple of interesting key points in this. So as customers' implementations really grow, we see lots of customers saying they start with one account, but pretty soon they have lots of accounts. Right? They like that the boundaries and the isolation boundaries of an account. So inside of an organization, people have lots of accounts. And inside of every one of those accounts, customers also like to have lots of VPCs. So we often run across customers who have thousands of VPCs. Hundreds, well, lots of customers have hundreds and some have thousands. They need things to share across all, they need ways to share across all of those accounts. So this is a capability to really share at the object level between many of those accounts. Particularly inside of an organization. A couple of cool things that this supports. You can have configurations in your license manager. So you can have licenses that work for your whole organization, and so you can share those across accounts in the license manager I mentioned earlier. You can have RF53 resolver rules that you can share. And then one in particular that I think is super useful, you can share a subnet. And what does it mean to share a subnet across accounts? Effectively, you share that subnet, and now you have a shared VPC. Many accounts can launch instances into that shared VPC and operate in that same context, even though the instances and volumes or databases belong to different accounts, and you can all operate on that same single network. Resource Access Manager lets you do that, control all of the security around it, and make sure that you have an environment that meets your needs. One more that I wanted to call out is Private Link. Private Link was a service that we launched last year at reInvent, and what Private Link allows you to do is create a private endpoint for your service. A common way that a lot of customers use this is to access AWS services. They have a VPC. They don't want an internet gateway on their VPC, but they still want to talk to Kinesis, or they still want to talk to the EC2 endpoints, or they still want to talk to any of our other system manager, any of our other AWS services. And so many customers will use Private Link to talk to those. Additionally, customers that are building microservices will put private endpoints on their microservices and use that as a way to easily set permissions around rules that they can communicate between all of their internal services, where if they have services running in VPCs, they can easily have endpoints to talk to them and set permissions and rules and exfiltration rules. A third way that I think is an interesting and emerging trend that we're seeing is we're seeing our ISV community offer Private Link as a way to securely work inside of AWS between our partner ecosystem. I'll use Salesforce here as an example. They're working on providing Private Link endpoints to all of their services, some using through Heroku or directly from Salesforce. Think about this as an example. You have a lot of your important company data inside of Salesforce. It's really critical. It's a lot of your sales leads, et cetera. Today, if you wanted to pull that into a data lake or something that you were going to build on AWS, you would have to pull all of that data across the internet. You have to go to the public endpoints, you have to pull it across the APIs, and it travels across the internet. That means that VPC has an internet gateway on it in order to reach your Salesforce data. That's a lot of risk that you're kind of taking with some really secure data that's really important and critical. With Private Link, you will be able to create a Salesforce endpoint, map it inside of your VPC, never have any of that data go across the internet, and pull all of it and combine it in a data lake together with the data you already have in AWS or other data sources, maybe your SAP instance that's running in AWS. You can pull all of those together and never have to expose that critical data to the internet. We think this is transformative to security and how people think about interacting with SaaS applications. And there's a number of SaaS applications from CA to Autodesk and a number of others available in the marketplace or available directly from these vendors that allow you to integrate with those via Private Link. All right, world-class networking and storage. Compute is super important, but without storage and networking, it kind of just sits there and thinks and doesn't do a lot. So it's an important part of having that, of having an important part of having a rich compute offering is to have a great network. Amazon has a global backbone, and Peter walked through a couple of things around global accelerator and some of our other network innovations on Monday that really make it easy to leverage the entire worldwide AWS backbone and network. From an instance level, we also think about networking not just at the global level, but at the instance level. And we've been rapidly improving the networking available on instances, as we talked about earlier, starting from a gigabit. We first launched up to 100 gigs that were available today on C5Ns. But if you think about it, inside of a data center, it is still kind of, or inside of an availability zone, it's still kind of a mess. I mentioned that many customers have thousands of VPCs. The way that you can connect from one VPC to another is many customers use VPC peering. That's point-to-point connectivity. If you think about 1,000 VPCs that all have to talk to each other, that is a lot of connectivity that you have to deal, and you end up with a diagram that's often much worse than this. Additionally, you have to connect VPNs to all of those different VPNs if you have an on-premise that you want to talk to every single one of those VPCs. And that can get hard to manage over time. You have to deal with overlapping CIDR rules. It can be hard. Today, or this week, we're launching Transit Gateway. It's already launched, and you can go test it out. Transit Gateway effectively moves this point-to-point networking into a hub and spokes model. It's a fully managed environment where you don't have to worry about any scaling, similar to like a managed NAT or something like that. The Transit Gateway allows for infinitely scalable bandwidth. It allows you to connect thousands of VPCs into the same transit gateway, and then have fine-grained controls around routing inside of that transit gateway. So you can control which traffic is allowed to go to which VPCs and how traffic should traverse inside of your network. Another of the cool things that this allows you to do is allows you to aggregate VPN or direct connect locations or connections. You can have all of your VPN connections connect into the transit gateway, or all of your direct connect connections connect into the transit gateway. And opposed to having single links also to every VPC, you can now aggregate those to have one really high throughput connection. And then every time you have a new VPC, as opposed to having it set up and having to have a new VPN connection, you simply just connect it to the transit gateway, and it takes advantage of all of the VPNs and direct connects that you already have set up. We think this is going to vastly simplify networking inside of AWS environment, and I've received a ton of early feedback from customers that they've really been waiting for this. All right, more Magic Quadrants. We're still up and to the left, but this one's on the storage front. Talking a little bit about storage. Storage is incredibly important, and we have a wide range of storage options. Andy spent a bunch of time on storage today, and that's because it's important to us, and we know it's important to you. You've got to have the right level of performance in storage for the right application. One he didn't mention a ton is around local instance storage. Local instance storage is a local NVMe, either an NVMe SSD or a spinning disk. It allows you to get great throughput, low latency, and many applications don't need the durability of something like S3 or EBS or things to store their data. They just need scratch disk, or they need really low latency data to compute on. We have a number of instance types that offer storage, and I think I wanted to call out a little bit of what we've done here with Nitro that has really helped us drive the latency down for our local storage. Here, we're comparing our own instance types. We start with I2 and then I3. These are kind of purpose-built, but on the old platform, purpose-built for I/O and low latency, consistent I/O. You see on one side the P50 performance on latency, and the next one the P99 on tail latencies. These are the best performing platforms we had under the old, and possible performance that we were able to eke out under the old platform. The next one is an R5D instance that's running on Nitro with a local attached NVMe SSD, where we take the I/O virtualization and move it over to the Nitro card. You can see that you get a pretty decent 50% bump in average latency, but you get a really big improvement on tail latencies. This makes a huge difference for high performance applications, not to slow you down at the tail. We also have a number of services. Many of these I'm sure you know about. From a block storage perspective, we have EBS, we have EFS for files, and we have S3 for storage, or for object storage. From a block storage perspective in EBS, earlier last week, you might have missed it, but we have many of different SKUs. Our most popular SKUs are IO1 and GP2 for low latency SSD access, and as well we have streaming options like ST1 and SC1 that are hard drive based instances, or hard drive based SKUs. On the SSD space SKUs, an IO1 in particular is mostly targeted at high-performance workloads and high-end databases. And last week we announced, and customers want to really get as many IOs as they can out of a single volume. Last week we doubled the possible number of IOs you can get out of a single volume from 32 to 64,000 IOPS from one EBS volume. And from GP2, which is our burstable volumes, We offered a 60% increase in the max number of IOPS that you can get out of a single GP2 volume. GP2s are used across the board for things like small databases, boot volumes, files, etc. And is by far our most popular SKU amongst all of our customers. Moving on quickly to EFS. EFS is a shared file system. It's incredibly popular. People attach it with NFS. It has been widely used. We also announced today support for FSX, which is a new file system, which is a managed file servers. This is effectively, when we talk to customers, a lot of customers have applications written to legacy file systems, whether they're Windows file systems or many of our HPC customers really heavily leverage Lustre file systems. FSX gives you a completely managed file system. What that means is you spin up the file system. You don't have to worry about patching. You don't have to worry about management. You don't have to worry about scaling. FSX does all of that for you. On the Windows side, it's fully Windows compatible. It has full SMB compatibility. It is a Windows file system. You can run Active Directory on it. You can use it as a SQL Server. Really, any Windows application runs great. We support high I/O workloads on Windows file system. And on Lustre, it's really designed for HPC applications. And as well as machine learning applications. We're often using Lustre as a great shared file system for ML. With our Lustre file system, customers can get hundreds of gigabits of throughput into the file system and very low latencies that you expect from that in a fully managed way. On S3, a couple of announcements I want to make sure you didn't miss on different S3 SKUs. I'm sure you're all familiar with S3. S3 is the building block for a number of applications across the world. A couple of cool things. Earlier this morning, we launched S3 Glacier Deep Archive, which I was kidding Swami sounds like a machine learning option, but it's actually not. It's actually an S3 SKU. And Deep Archive is effectively, it's similar to tape. It's our tape replacement. For those kind of workloads, think like medical records or long-term archiving of files that you rarely are ever going to need to access. Deep Archive has an SLA where you can get your files back, but it's in hours, not minutes. But it's 75% cheaper than Glacier. I also heard today, as a point of comparison, S3 Glacier Deep Archive is now 94% cheaper than standard S3. That is a pretty awesome cost drop for objects that you don't need to use very frequently. But for many of these, and the other one that I make sure you didn't want to miss is S3 Intelligent Tiering. I think this is one of my favorite ones as well. A lot of customers struggle to know, should I store my objects in standard S3 or should I store it in infrequent access? I don't know if I'm going to access it. I don't want to have to pay the penalty for accessing it if I'm wrong, but I really want to take advantage of the lower cost of infrequent access. S3 Intelligent Tiering uses ML behind the scenes to move your data from standard to infrequent access when we think that it's being colder, or then it's colder, and you get to pay the lower rates when we move that. If we're wrong and you do go access it, you don't pay any access rates and we move it back to the standard tier and you start saying standard prices. I think customers are really going to enjoy not having to think about how they classify their data and just put it in there and take advantage of lower costs. All right, abstractions for managing cost and complexity. We're going to go through these pretty quickly. There's a couple of really cool ones here that I do want to highlight, though, that are new. One of those is, you might have missed this. I think this happened last week. We have a capability in EC2 we call EC2 Fleet. Fleet allows you to pick a wide range of options that you want to launch and how you manage a fleet. It lets you run spot and on-demand instances in the same kind of launch configuration. It lets you launch across instance types. M5, C5, M4, et cetera, kind of lets you have a whole fleet of instances. And if you think back to the Western Digital example, this is how they were able to scale up to 1 million cores, is they design a fleet of instances where they say they can take any of those. And new is that EC2 Fleet is now integrated into autoscaling. So you can define your autoscaling group as an EC2 Fleet template, and you can scale on-demand and spot via Fleet inside of an autoscaling group. It's pretty cool. A new thing that we're also announcing is Hibernate. We support a small number of operating systems to start with, and we've supported this on Spot for a while, but we're now going to be supporting this for on-demand instances, where you can shut down your instance, kind of save the state of the memory, and then come back and resume in the exact same place. As I mentioned, this is supported for a small number of operating systems to start with, and we'll be adding more of them over the next coming weeks and months as people take advantage of that. All right. Another one, predictive autoscaling. This is something that customers have been asking us for a while. If you look at the first graph here, this is what it looks like if you have to provision capacity on-prem, right? You don't know when the peaks are going to happen. You have to order servers, and you are way over provisioned, and the cost is up there. The second one is what traditional auto-scaling in the cloud looks like, and target tracking, right? Where you scale kind of just behind demand. As demand comes, you add more instances, but it's just behind demand. So you always have a little bit less of capacity than you want as you're scaling up. And then as you're scaling down, you have a little bit too much capacity. Predictive scaling looks across millions of data points in the AWS cloud, looks at historical trends both for you and other customers, and predicts when your traffic is going to go up, and scales for you ahead of when we think you're going to need demand, and scales down along with when we think demand is going to go down. Helps you save money and make sure that you have enough capacity when you need it. All right. This is an example of, I want to talk a little bit about a really cool customer case. Milk is a small visual effects studio. And small is interesting. This is different layers of rendering a movie called Adrift. It's about a couple of sailors who get lost at sea, and they have to go model a bunch of really hard things there. It turns out that fluid dynamics and modeling the ocean is actually really, really hard. Milk, as I mentioned, is a small studio. Typically, these kind of visual effects would only be available for a really large studio, somebody like Lucasfilms or something like that was going to be able to do this. Milk, however, because they run on AWS and ThinkBox, and ThinkBox is a company that we bought, we make it really easy for them to actually put together their rendering workloads and put those in the cloud. They ran over 130,000 cores for several weeks and won an Academy Award for much of their work, as they were able to compete with larger studios for offerings and projects such as this one. They were able to complete some really amazing looking scenes. They won some awards for them, and these are things that, if you think about kind of how they would have modeled it, it only would have been DreamWorks or some of the biggest studios that ever could have won this deal. But with AWS and with ThinkBox, that makes it simple for them to think about it. They don't have to think about how do you cobble together all of these services. Milk doesn't actually have to be an AWS expert. ThinkBox makes it simple for them to just go and render all of these and push a button and run them all in the cloud, and they can run at the scale and compete with the larger studios. Another service that we have that makes it easier for customers to consume compute is Lightsail. This is kind of at the other end. This is not about consuming 130,000 cores or 2 million cores. This is about running, a simple WordPress app. A lot of our customers said when they first started it, they want to use EC2 for something like WordPress, but it's complicated. You got to think about VPCs, you got to think about subnets, you got to think about IAM roles, etc. Lightsail makes all of that easy for you. It picks intelligent defaults for you. It runs it. It makes it easy with the simple 2 or 3 clicks. You can be up and running and have your WordPress running. You're on the power of AWS. It's the same reliability, same security, same great performance, but we really make it simple. We've been launching a number of features that make it, you can add more complex applications on top of Lightsail. We have a managed database offering. We have a load balancer. And today, we're really happy to announce that you don't have to worry about, wait, what if my project gets big? Am I going to have to go rebuild this on EC2? We're launching the ability to easily move your Lightsail implementation, if your project ever gets big, over to EC2, where you can take advantage of the full suite of capabilities if you ever need to do so. So customers don't have to worry that they're getting locked into a simple platform that's easy to get going, but it won't be able to scale with them. So easy to launch, easy to grow. All right. Last one, compute everywhere. Now, global compute platform. When you think about compute, people, everybody's applications are thinking about global from the very start. And that means you have to have infrastructure everywhere. If you look at the graph up here, or the chart up here, we have regions all around the world. We have POPs all around the world for CloudFront. We have direct connect locations almost everywhere, so it's easy to connect wherever your data center is. 19 regions, 57 availability zones, 150 points of presence, 89 direct connect locations. We really have a globally distributed footprint. But when people really think about computing everywhere, they also think about hybrid. And you heard this announcement earlier, and I want to go into some more details that Andy didn't have time to share about how we think about hybrid. When I talk to customers and they really think about hybrid, they say, look, I want it to be the same. Hybrid means it's a different location, but I want the same software, I want the same services, I want the same infrastructure. I don't want to have one mode of development over here and another mode of development over here. I don't want to have to use one set of management tools and then a different set of management tools. I want it to be the same. That's really hard. Turns out people have been asking us for that since we launched AWS, and we hadn't thought of a good way to do it until now. And really, it's Nitro that's enabled us to do that. So today we announced AWS Outposts. And what Nitro enables us to do is we have a complete secure compute environment inside of an outpost. Outposts are AWS hardware that you can buy, that you can order and install in your own data center. It's designed for a data center environment, but all you need is power and network. You plug it in, and it's ready to go. The instances will show up in your VPC, or the capacity will show up in your VPC. Think about it as you'll have an isolated subnet. But other than that, the only things that are in your data center are just the compute and storage capacity. That means that when you want to, you have that fully managed infrastructure. Okay, when you want to, excuse me, when you want to launch an instance, you talk to the regular public API. You call run instances, and the same API you use today, and you just target the subnet. That's your private subnet of your Outpost capacity, and the instance will launch in your data center instead of in the public cloud. When you create a volume, you just create a volume using the public console. You can go to the AWS console, create a volume, target it to a subnet. It'll show up on your capacity as opposed to inside of the AWS cloud. Other than that, it's the exact same. The hardware is managed as well. You think about the servers here, kind of the mental model for these servers that I like to use is kind of a non-ruggedized snowball. If something breaks, if a power supply goes bad or something like that, you simply pull one out, let us know, we'll mail you another one, you pull it back in, it's back up and running. And there's nothing to manage. From our developers' perspective, this is just capacity. We'll simply patch it, upgrade it, do everything on the software side, just like we do for the rest of an availability zone. You think about it as an extension of your VPC or an extension of a local availability zone, but designed for low latency use cases in your data center. You configure a single instance. You can either buy a single instance or multiple racks. You can deploy it on your own, or we may even be able to come and help. But you use everything else the same. You use your same identity, and your same security, you use the same logging. You can use the same CloudFormation templates, the same AMIs. Everything is the same. There are two versions that you can buy with regards, or that you can order with regards to Outposts. You can do the AWS native version, or you can do the VMware version. Many of our customers use VMC, or VMware Cloud on AWS, and they love that managed environment. Turns out that managing a VMware cluster is also a lot of work. You got to patch it, you have to upgrade it, you have to do a lot of those things as well. On VMware Cloud and AWS, you don't have to do that. With VMware on Outposts, you get those same benefits. A fully managed environment, fully managed hardware, but the full native VMware stack that you can control with vSphere just like you do. So our goal is to let you run AWS anywhere that you need it to be. If you want to run your code on Greengrass, if it needs to be on IoT applications or things like that, you can run it on IoT. We also launched a couple weeks ago Snowball Edge. Snowball Edge is designed for disconnected environments where you need a little bit of compute and a little bit of storage, but maybe you're in a ruggedized environment, or you're on a ship, or you're in a mine, or somewhere else that doesn't have great network connectivity. Snowball Edge is a great option. If you have a data center and you really need, from a latency perspective, you need that work to be close to the things that are in your data center. Examples that we really when we talk to customers of when this is super important. I was just talking to some folks from Netflix yesterday, and they say they have some artists that are in LA and animators, and they need that compute running the virtual workstations to be really close to those developers that are in LA, so they can have really low latency to their animation tablets. This Outpost is a great example for them. I talked to another customer who has huge amounts of data on premise, and they would love to use our host of EMR options or EC2 directly or some of our other analytics services to compute on that data. They eventually want to move that data to the cloud, but they don't know how or when or eventually how that's going to happen. Now they can take Outposts, put those in the data center, move some of those analytic applications into a native AWS environment where they can launch instances or EMR clusters or things like that and compute on that legacy data set. A third one is thinking about network operators or telecom operators, where they need to have compute close to the end 5G controls, where they're going to do network virtualization functions. The latency required to really control a lot of those base station requirements are very tight. They can't afford to have that latency that goes all the way back to the AWS cloud. Outpost is a great solution for those. We think that there's a wide range of use cases where customers are going to be interested in Outposts, and you expect those in the second half of 2019. So look forward to hearing how you guys think about using those, and look forward to hearing feedback. We'll share more data on those as we get it, but we're excited about what the potential. All right, so that basically walks you through the compute program, or the compute platform for the world. There's a ton of new features and functionality that we've announced so far this week. There's some more that are coming in the keynotes for the rest of this week. Here's a quick recap of several of the announcements that we've made. I also want to encourage you a couple more breakout sessions for a number of these. Dave has a networking session, a deep dive on EC2 networking that's going in just a little bit. Joshua has one on how to save costs in the AWS cloud in EC2, and I encourage you to check that out. That's always a very popular session. Sandy is going to be talking about enterprise workloads and Windows and some of the innovation of the 10 years that we've been running on Windows. And then Deepak leads also a very popular session on Thursday after Werner's talk, talking a lot about serverless and containers and DevOps, and he's going to be doing that together with David Richardson, who leads our serverless efforts. All right, I think that's it. Thank you very much, everyone, for coming, and I hope you enjoy the rest of the week.